Chapter 7 in, this is the Algebra 1 Structures and Method, Book 1 by McDougal, Littell, with our favorite author, who is Mary Dulciani. Excellent writer of math content. But this is Chapter 7, Applying Fractions, 7-1, Ratios. We're going to complete all of Chapter 7.1 over this Easter break here. And we're going to deal with ratios. So what we want to see is a ratio. Ratios can be written in 3 different ways. It can be written, it can be written like that. That is 2 different ways of writing division. And then you can see it with the semicolon, or the colon, sorry. Write each ratio in simplest form. That means we have to reduce them. So we're going to change it from a ratio to a fraction and then reduce it by the greatest common factor, which is 9 in this case. And whether they have variables shouldn't change. You're going to just find a common factor of those. So we're going to write 12/18. Now we can do it with the GCF, which would be 6 in this case. Divide by 6, and we get 2/3. Or if you don't see the GCF, you can just divide it by a common factor. So there's a slight difference between a GCF, which is the greatest common factor, and a CF. This is just a common factor. Now, a common factor will reduce it, but it doesn't reduce it completely, meaning we would have to reduce this one more time by 3, which is a common factor again, and you get 2/3. So there's 2 ways of going about doing it. One is more efficient than the other, but both techniques will get you to the simplified version. 42/35, we're going to reduce it by 7. And we should be able to see common factors. Simplifying is not this. This is not simplifying. This is called converting. That's converting. You're converting from an improper fraction to a mixed number. That is not simplifying a fraction. Very important concept to be able to understand. A lot of students. Now, here is an issue that students get into. Well, 9 doesn't go into 30. And they think that it has to go into, that the numerator has to go into the denominator of some sort. No, it just needs to have a common factor, which would be 3. And we get 3/10. So a lot of students think that this is simplified because 9 can't go into 30. That's not the case. That's not how we simplify. We're going to simplify by 5/5, which gives us 3/15. I think it's 15. Oh, look at that. And we notice that we're not done, that we can still simplify by 3, which is 1/5. So that is a great example where we chose just a common factor, not the greatest. And we always have to check, make sure that we still can't simplify after we reduce it by a common factor. Right, so is that good? Yeah, 5, 7, yeah, that's good. Here's our first variable one. And so 18x/27x, we can reduce it by 9x. And that would give us 2/3. The other way is you can just reduce it by x first, which gives you 18/27, and then reduce it by 9, which gives us 2/3. 9y/48y. The y's definitely going to cancel. What's that? so 3. I'm going to divide by 3y. And that gives me 3 over 16. And 3 over 16 cannot be reduced. 3 does not go into 16. Ooh, 6a squared over 12a. I didn't show you the other way. Oh, I forgot this technique. We could also break it into its prime factors. And then you can cancel. The a's cancel, the 3's cancel, the 2's cancel, and you're left with a over 2. Not the best way. That's not the most efficient way. It's way, way better mathematically, conceptually, going towards high school to find the common factors. So that gives us a over 2. Same thing. So this is an okay way to build into it, but this is the high school way. This is the high school method. 30x over 6x. We're going to reduce it by 6x. 5 over 1, which must be written as 5. Write each ratio in simplest form. That would be interesting. Let me check that answer. See if they keep it as a ratio. I would be very interested to see number 8's answer. Yeah, they did. Since they want it as a ratio, all of these are incorrect. They want it as a ratio. So yes, a fraction, but I guess they want it written like this. So if we were going to write it as a ratio, we would write it 6 to 5. 3 to 10 is simplest ratio. 1 to 5. And 2 to 3. And 3 to 16. And this is the fun. Nope. A to 2. And this is the one. That's the tricky one. So you would write it as 5 to 1. I don't know. So we have to simplify this, which is a to the 4th over 4a squared. Now we can reduce it by a squared. And we get a squared over 4, which would be written in the ratio. I like both of these. I think it's a form, so I didn't do it incorrectly per se. No, let's just go. No. 45m to the 3rd. Let's reduce it by 5m to the 3rd. And this is where finding the greatest common factor mentally, opposed to the technique that I showed you in chapter 6. This saves you time. And so that's where the efficiency comes into play, where we don't have to do the prime factorization, circle the common, and then use it as our greatest common factor. Being able to visually see coefficients. So we're looking at the coefficients here. We're looking at 56 and 14 and seeing that 7's our greatest common factor. We look at a squared and a would be our greatest common factor. B and b cubed would be b. So we're going to take all those little components, divide by 7ab, divide by 7ab, and we get 8a over 2b squared. Oh, I didn't do the biggest. So we can still do 8 and 2, excuse me, and we can reduce that by 2, so we get 4a over b squared, or 4a colon b squared. Either of those, to me, are acceptable. 36rs to the 4th, 12r squared s squared. Let's reduce it by 12r s squared. 12r s squared gives us 3s squared over r, or 3s squared colon r. Those are good ones. All right, write each ratio in the simplest form. Oh, so yeah. Let's look at those examples, because they said fraction is okay. Let's look at these examples. Yeah, so we could write it as a fraction or a colon. Notice we could have given either format. So those are fine. Those are okay. Mr. Mac did okay. And we can still do that. So now we have units. So this is good. I like this section. This was always fun. So 20 seconds over 1 minute. I'm going to convert 1 minute. Oh, let's see. Let's do this. Let's get rid of the minutes. So 1 minute equals 60 seconds. Yep. And so these are going to cancel. And now my seconds are going to cancel. And my zeros are going to cancel. And my 2 is going to cancel. And my 6 is going to be a 3. So I think, methinks, it's going to be 1 to 3 or 1 to 3. Let's see. And check our answer. Make sure that we are comprehending it correctly. 1 to 3. All right. And this is called a conversion box, is what I call it. And that's an equivalent of 1. 1 minute is equal to 60 seconds. Why did I put minutes in the numerator? So they could cancel with the denominator. So I want those units to cancel. 6 days over 2 weeks. So I'm going to write a conversion box with week. 1 week is equivalent to 7 days. And that 1 week, excuse me, that's not true. The unit week will cancel with week. 2 will cancel with 6. Let's see if that works. That was kind of weird. Days. Does that equate to 3 over 7 or 3 to 7? Let's see. Let's see how unsure I am of myself. 3 to 7. But he's on. He is good to go. 2 feet is to 1 yard. So we're going to do a conversion box. 1 yard is equivalent to 3 feet. My yard, my feet, my lord, 2 to 3. Either one is okay. That's good. 12 centimeters, 1.2 meters. So I'm going to do a conversion box. 1 meter is equivalent to 10 centimeters. Meters cancel, centimeters cancel. 10 becomes 5, 12 becomes 6. What should I have done? Yeah, we'll see. All right, now we get 6 over, oh yeah, fine. 6 over 6? Shush, is that 1 over 1, which equals 1, or 1 to 1? No, maybe. What number is that? 16. 1 to 10. Where did I forget my, where did I make my mistake? Centi, 100. Found it. 100 centimeters, Mr. McCausland. 100 centimeters. Yeah, that was bad. That was a bad one. So 56, 6 goes 3, 50 goes 25, and then This is not going to be fun. 3 over 25 times 1.2. 25 times 1.2. 30. 30, which reduces to 1/10, or 1 to 10. And that makes sense. 12 centimeters, 1.2 meters. Ooh, 8 ounces to 1 pound. I think there are 1 pound is equivalent to 16 ounces. Is that correct? Ounces, I think 16 ounces in 1 pound. We'll find out. How many ounces are in a pound? 16. He was correct. Let's do some canceling. Ounces, pounds, 8 is 1/16 is 2. So it is 1/2, or 1 to 2. Is that correct? Wow, why do I feel like it's 1 to 4? Oh no, ounces. No. That was 17. 1 to 4 is correct. Did I do 1 to 2? Yeah. Where did I make my mistake? Because it's not 2. It's not 1. It is 2. Wow. Making some silly mistakes, Mr. McCausland. Making some very silly, fast mistakes. Let's slow down a little bit. 1 day, 30 hours. So we have, let's do 24 hours to 1 day. I don't know which way they want us to convert, but we'll do that, which is 12, which is 15, which is 4, which is 5, which gives us 4/5, or 4 to 5. 4 to 5 for number 18. 4 to 5. Okay, we're back on the track. 5 meters is 250 centimeters. So let's do this properly. 1 meter is equivalent to 100 centimeters. And the way we remember that is King Hector died, unfortunately, drinking chocolate milk. And this is our unit of, so going here is 2 spaces, that's 200, to 100. We're going to cancel the meters, we're going to cancel the centimeters, we're going to cancel one of the zeros, we're going to cancel the 5 and the 25, which makes 5, and then we're going to cancel the 5 and the 10 to 2, and we get 2 over 1, or 2 to 1 for 19. 2 to 1. 4 hours, 30 minutes. We're going to convert 60 minutes is equivalent to 1 hour. Hours are going to cancel, minutes are going to cancel. 30 goes into 60 twice, and we're left with 8 to 1, or 8 to 1 ratio. Yeah, there are 8 30-minute increments in 4 hours. 1 pound is 6 ounces, as 1 pound is to 16 ounces. And remember, I put the pounds in the denominator so it can cancel with the original pounds in the numerator. That's my reasoning behind that. 6 and 16 is 8 and 3, so we get 8/3, or 8 to 3 for 21. All right, we're good. 8 weeks, 1 year. Ooh, 8 weeks to 1 year is fine. We have 1 year, and we have 52 weeks in a year. Doesn't seem like a lot when you think about it. 52 is kind of small. We got 4 divided by 2. Well, 4 goes in both of those two. 2, 8, does 8 go in? No, 8 doesn't go. 4 goes in 8 twice. 4 goes into 52. Yes. 13. So 2 to 13. So 2 to 13 ratio. 2 to 13. Yep. We're, kilograms. 3 kilograms to 150 grams. Again, King Hector died, unfortunately. So we have 1, 2, 3 zeros. So an equivalency is 1 kilogram is equal to 1,000, or 3 zeros, grams. Remember, kilo is bigger. So kilograms cancel, grams cancel. That 0 cancels. 3 cancels with 15 is 5. 5 goes into 100 20 times. So we get a 20 to 1 ratio for number 23. Did we just, no, different one, okay. So 6 kilograms to 120 grams. Same conversion unit. We have 1 kilogram equals 1,000 grams. We're going to cancel kilograms, grams, grams. One of the zeros, one of the zeros. 6 goes into 12 2 times. 2 goes into 100 50 times. And we get 50 to 1 or 50 to 1. We are good. Let's change it up. Write the ratio of wins to losses for a baseball team that played 72 games and won 45 of them. 45 wins out of 72 games. Wins to losses. This is the important thing. So we have wins over losses. So that's why we have 45 wins. And then we had to subtract 45 from 72, so give us 27. And then we're going to reduce it. And we're going to reduce it by 9. And that gave me 5 over 3. Or 5 to 3 ratio of wins. 5 wins for every 3 losses. So a teacher... student teacher ratio in a school with that many and that many teachers. So 132. So if there were 2,376 students, 76 students to 132 teachers, can we reduce that ratio? 11? I think 11. Let's see, 11, because 132 I know is 12 times 11. So either 12 or 11 that goes into 2, 3, 7, 6 divided by 11, 216. 216, and that goes in 12 times, and then we can reduce that by, well, let's start with 2. So that's 108, that's 6. We can reduce that by 2. Actually, we could have reduced it by 6. 6? Yeah, 6 goes in 1, 8, 1. So 18 to 1 ratio of students to teachers. Students to teachers is 18 to 1. Yes, let's go. Sunny days. Sunny days. Cloudy days. 365 days. 275 are sunny. Now we got a minus 275, 0, 90. So 90 cloudy days. Are we in California? And we can reduce that by 5. 5, 6, 5, which gives us 55, and that gives us 18. I think that's 18. Should be 18. 55 and 18. So 55 to 18 ratio for number 26. 55 to 18, sunny to cloudy. The ratio of two-door cars to four-door cars in a rental car fleet of 600 cars, 250, which are four doors. So two-door to four-door, and there are 350 four-door, and so there are 250 two-door. We can reduce that by 50. And how many 50 cents are in $2.50? That would be 5 and 7. So 5 to 7 ratio. 5 to 7 is correct. All right. Ratio of boys to girls in a school of 1,200 students. If 660 students are girls. Boys to girls, 660. So that's 540. I think that's 540. Yeah, 540. Let's reduce it by 20. I don't know. Let's start with 20. So that's going to be 27, and that's going to be 33. We can reduce that by 3, and we get 9/11ths. So 9 boys to 11 girl ratio. For number 28, 9 to 11. Good. See how efficient? We want to look for ways to do it efficiently, where we can do problems within 10 seconds. The ratio of men to women, and an audience of 120 out of 30 are men. So reading that, we see that 120 are men, and then the remaining, which is 280 of those 300, are women. And so we can reduce that by 20 again. And that's going to give me 6 over 14, which can be reduced by 2, which gives us 3/7. So 3 to 7 in men to women. The ratio of women to men in part A. Well, that's A. So women to men would just be 7 to 3. Ratio of men to women, ratio of women to men, yeah. 29. 2 to 3. What did I do wrong? What did I do wrong? Half of 28 is 14. Whoopsies, what did I do? 120. Oh, that's 400, sorry. It's 180. 180, sorry, 180, which gives us 9, right, which gives us 2/3, sorry, 2/3, 2/3, and then 3 to 2. Let's check that, 29, 2 to 3, 3 to 2. Okay, we found our mistakes. We make mistakes. Everybody's going to make mistakes. Ratio of fiction to non-fiction books in the library with how many fictions and this many non-fiction. So if we reduce that, that's just going to be, well, let's make it easy. 176 divided by 2 is 55. There's 11 in there again. No, we're going to divide it by 11. That's going to give us 16, and this is going to give us 10, which is 5/8. So 5 to 8, fiction to nonfiction, ratio of nonfiction to fiction books. Okay, that's not that much more difficult to reverse the two numbers. Not sure why they do that. That's kind of simple. A rectangle with sides 10 centimeters and 8 centimeters, and one with sides, what is the ratio of perimeters? So A is talking about perimeters. We have one rectangle that is 8 by 10. We have another one that is 15. That's not a 15 by 12 centimeters. So the perimeter is going to be 2 times 10 plus 2 times 8. So the perimeter is going to be, what's that? 20 plus 16, 36. And the perimeter here is going to be 2 times 15 plus 2 times 12, which is going to be 30 plus 24. So the perimeter is going to equal 54. So that ratio of the perimeters is going to be 36 to 54, which goes in 6 times, and that's going to be 6 over 9. And that's going to be 2 over 3, or 2 to 3 perimeter ratio. That's number 31A. 2 to 3, good. And now, part B. Part B is area. Love it. This is a great question. So, B, area of the first one. Let's keep writing in black. Area is going to equal base times height, which is 10 times 8, which is 80. And this is going to be 15 times 12. 15 times 12, which equals 15 times 12, 180. 180, and now our perimeter is going to be 80 to 180, which is 4 over 9, or 4 to 9. 4 to 9? 4 to 9. We are doing this all well. Rectangle with sides 12 inches. 12 inches to 16 inches. And one with, I'm just making sure that they stay in the same units, 15 inches to 20 inches. So perimeter, 2 times 12 plus 2 times 16, which equals 24, plus 32, which gives us 58. And we have a perimeter of 2 times 15 plus 2 times 20, which is 30 plus 40, which is 70. And we get 58 over 70, which is 29 over 35. I think that's it. 29 to 35 ratio of perimeters. I made a mistake. I made a mistake. 24, 6, 6, 12, 32, 58. That's correct. 30, 40 makes 70. Half of 58. 9 9 is 18. 29. That's right. 70 is 35. 12 and 16. 15 and 20. 24, 6 and 6 is 12, plus 1 is 32, 6, 56. 56, Mr. McCausland. We're making mistakes again. 28 and 35, 7 goes into that, right? 4 to 5. 4 to 5 for A. 4 to 5, sorry. And if we're going to do area, B, area equals 12 times 16. 12 times 16, 12 times 16, 192. And area equals 15 times 20. Which is 300. So we got 192 over 300, which is 96 over 150, which is 48 over 75. 48 and 75. 75, 15, 5. Hmm. 6 and 8. No, those won't. Did I do those wrong? Let's see. 9 9 is 18, 6, 192, 300. That's correct. 75, 15. 3. Oh, hello. 3 goes into it. 3 goes into that twice, 25. 3 goes in that 1, 16. 16 to 25 is the ratio. Didn't see the factor of 3 rule. A rectangle with a length of 18 and a perimeter of 84. Okay, now we got to do a little math. 18 and x, but the perimeter equals 84. So 84 equals 2 times 18 plus 2 times x, which is 84 equals 36 plus 2x minus 36. 7, 4, 8 equals 2x divided by 2, and we get 24 equals x. So one of the sides is 24 centimeters, and one with a length of 15 and a perimeter of 70. All right, so, well, we're going to do perimeters. Hello, they already gave us it, but we would have to find it for an area. But so let's keep going. Perimeter of 70, 15 centimeters. So 70 equals 2 times 15 plus 2 times x. 70 equals 30 plus 2x minus 30. 40 equals 2x. Divide by 2. 20 equals x. So this is 20 centimeters, but perimeter, we can just do 84 over 70. So we didn't have to do any of that. Nope. Perimeter is what I say, 84 over 70, which is 42 over 35, which is divisible by 7, which is 6/5. So 6 to 5 ratio for perimeters. And area, now that we know the sides, B for area, area equals, was it 18 by 24? Which is 18 times 24, 432, 432. And the area of this one is going to be 15 by 20, which is 300 again. So that area ratio is 432 over 300, which is 2. 1, 6, and 150. 3 goes into those. 3 goes into that 72. And 3 goes into that 50. And we can reduce that. Goes 36 and 25. So 36 to 25. Let's check that one. I'm not super confident on that one. 36 to 25 is good. Okay, these are getting long. But again, I tell you, do as many practice problems, you become proficient, and a perimeter of 100. So we're going to skip to it because we know that perimeter is 100 over 150. We're going to have to do that silliness. 50 goes into that twice, 50 goes into that 3, so 2:3 ratio. We could cut to the chase, kids, for the perimeter one for 34. And now we have to do a little math for area. So we got to look at that perimeter of 100, length of 20, so 40, 60, so 30. And we got our perimeter is 150, length is 30, 60, that's 90, that's 45. I think that's correct. So area of this is going to be 600. Area of this is going to be 90, 120, 1200. I did math in my head. Be careful, kids, when you do math in your head. Thank you. 1350. Let's make sure I multiplied 30 times 45. 1350. Hence why we don't do it in our head, because we're going to be wrong most of the time. We get 600 over 1350, which is 60 over 135. 5 goes into that 12 times. 5 goes into that 27. And 3 goes into that 4 times. 3 goes into that 9 times. So 4 to 9. In the area ratio, 4 to 9 is correct for 34. Square with sides of 75 and one with sides of 1 meter. So notice different units. The perimeter. So 1 meter is going to be 100 centimeters. So perimeter, let's do perimeter first. So that's going to be 75 times 4, which is 20, which is 28, which is 300. And perimeter is 100 times 4. So a 3 to 4 ratio of perimeters for 35. 3 to 4. Good. Area. So we're just going to 75 times 75. This is B. 75 squared, which is a big number. And 100 squared, which is a big number. 3, 4. 75 squared. Kids, know your squares. I don't expect you to know. 5625. 5625. So 5625 over 10,000. And that's going to get, yeah. Okay, well, let's do by 5. We can do by 5. That's going to give us 2,000. And 5 is 1, 1, 2, 5. And we can divide that by 5, which is 400. And that by 5 is going to be 2, 2, 5. I'm getting a little sloppy here. That's 80. And 5 is going to be 45. And by 5 is going to be 9 over 1, 16. 9 to 16. If this is right, so much mental math. 9 to 16. Let's go. I got lucky. I did a lot of the work in my head, but I'm pretty good with numbers because I work with them all the time. 36A, a square with the sides of 18, 2 yards, 2 yards, inches. So there are 6 feet, and 6 feet is going to be 6 times 12, which is 72 inches. So that's what they're trying to do there. 18 times 4 is 32, 72. And perimeter of 72 times 4 is 288. 72 over 288
reduce that 8 and 8, 16, 17, 18. 9 goes into both of those. 9 goes into that 8 times. 9 goes into that 3, 32. I could be wrong, but we'll see. That's going to be 1 to 4. Perimeter, 1 to 4 for 36. 1 to 4. Yep, it's better to be lucky than good. Now let's do our area. That's going to be 18 squared. That's going to be 72 squared. Numbers, I don't know. Watch this, kids. No calculator. 18 squared is 18 times 18. Remember, we're making a ratio of it, 72 to 72. So let's just reduce it this way. So I know 9 goes into both of those. 9 goes into 18 twice. 9 goes into 72 8 times. And that goes in that one also. And then 2 goes into 8 4 times. 2 goes into 8 4 times. So we get 1/16 or 1 to 16. Please tell me that's right. No calculator. 1 to 16. Ratio of areas. Find the ratio of the perimeters in there of each figure. Where are the figures? I think that was it.
I think that was the last one.
It was. All right. Good practice. Good on your multiplication. Check your work. If you provided a calculator, check your work on a piece of paper. Good luck with this.